Welcome, everyone. Good afternoon to those of you in Europe, good evening or late night in Asia, and good morning to those in the North American, South America. We have an action-packed, interesting webinar here for you on Industry 4.0 and closed-loop manufacturing. My name is Knud Lasse Lueth, and I'll be your host during this webinar. About the webinar, just very quickly, it's an hour. We'll try to keep 15 or 10 minutes at the end for Q&A. In case there's a question, we are recording this. We will be sending the recording to everyone who attended, and we would really like to hear your satisfaction at the end. And then there is an element of Q&A, so if you have questions as we go along, please feel free and send us those questions. We try to get to them at the end. Today's speaker, I'm the person here on the left. I've been running IoT Analytics and doing research for the last 15 years. With me on the call today is Fernando, who's focusing on some of the industrial IoT topics. And we have a guest today from Brügge and from the 𝗵𝗂𝗃𝗀𝗃 platform, Raphaël Müller. We've actually had a webinar together already a few years ago, and it was very insightful. I'm very happy that we can bring Raphaël and his insights back here, who will present quite a bit on how they are implementing closed-loop manufacturing. Just very quickly, if you don't know us, IoT Analytics, we make market research for IoT, AI, cloud, edge, and Industry 4.0. We make a lot of reports, and we will share some of those research insights that are in our reports today. So let's get started. Let's talk about the state of Industry 4.0 and smart manufacturing. Then, after a while, go a little bit deeper into this specific topic of closed-loop manufacturing. And then we will have Raphaël tell us all kinds of insights from his side. So very quickly, just to get started, just to get everyone on the same page, Industry 4.0. You may, at this point, be familiar with it because it was originated more than 10 years ago out of Germany. There are a lot of similar concepts: smart manufacturing, smart factory, industrial IoT. They're not all the exact same thing, but the idea is that it's the fourth industrial revolution. And one of the things we in our research always like to do is we like to look at, well, let's look at Google Trends. Let's see what topics are people looking for on Google, because it gives us an idea how hot, so to say, the topics are. So Industry 4.0 wasn't even existent on Google really pre-2014, had a really long period where it took off. Then COVID hit. I think the topic was a bit deprioritized. And we've recently seen a resurgence of all Industry 4.0 related topics, and you can see that in the searches. We're not exactly where we were at the end of 2019 yet, but we're getting there again. It's quite encouraging, I would say. So just we've shown these before, but just for common understanding, Industry 4.0 means basically in the industry and manufacturing vertical, really looks at not only the tech stack, but also additive manufacturing, collaborative robotics, AR, VR, those things. IoT is a bit more clearly focused on the tech stack, but also outside of industry. And then within Industry 4.0, I think it's always very important to clarify when you talk to someone, are they talking about their own smart operations? Are they talking about smart products that they are selling to customers? Both of them can be Industry 4.0, can be IoT, but it's two different worlds in many cases. Yeah, and with that, just as a starting point, we have some data that we're presenting today, a lot of which is from our recent Industry 4.0 adoption report we released in October. We surveyed a number of manufacturers on Industry 4.0. You can read a blog about it on the website. You can, if you're a subscriber to our research, you can see the entire thing and look at the data. I'm presenting a few snippets. Before I present snippets of that report, I think it is relevant for everyone to see how bad is the current economic environment for Industry 4.0, just simply because we are bombarded in the media by news about a downturn, about inflation infecting us, and just a bit of data from our research desk. One being job data. We index the amount of open positions for Industry 4.0 related jobs to November last year. So you can see topics around cloud IoT platform, and we did this where we have more research. If you put AWS in there or put Azure in there, you see open jobs have come down like 30–40% across the board in the world for these topics. At the same time, for topics like digital twin, predictive maintenance, machine vision, robotics, holding up quite well, is actually above the levels from a year ago. And so that leads us to conclude that yes, they are declining, but you know, not to a degree that we have to say we're majorly worried. And just to give you a bit of feedback from last week was the SPS fair, so Clear Industrial Automation Fair here in Germany. We interviewed a number of people and we asked everyone what's happening with the economy. So we did a bunch of things, and we're actually releasing a report on that next week of our takeaways from the fair. But here you see industrial software vendor, they told us no signs of economic slowdown for us whatsoever. A large industrial automation vendor, no downturn visible. They were a bit worried if China has a continued shutdown, maybe that has an effect, but not really. Industrial connectivity companies that we're seeing some churn, and some customers are asking for discounts, but really it's going well. And then lastly, another medium-sized automation vendor where I don't see any real signs of a slowdown. The person actually told me the exact opposite. He said, look, we used to have 3 to 6 months visibility on our order book, and our orders are filled for the next 2 years. So I had extremely positive feedback from various people that I think is genuine. So our conclusion is that even though there are clearly pockets of weakness, generally speaking, this whole Industry 4.0 world, and also looking at the Google trend chart, which was going up, it's not really that affected. And you may ask yourself why, and I think that gets back to the research question of, you know, that I think we have some answers to that in our data. So first of all, 72% of manufacturers that we surveyed have a smart factory strategy. A lot of them also have an IoT strategy. Some of them may be synonymous, some may not. Have an AI strategy, 53%, and some have a smart connected product strategy. You may note some have no plans at all for this, because in some industries, it is a little bit difficult to produce smart connected products if you're on chemicals or something similar. The interesting part is that the ambitions for the next years are really high. So if we asked a bunch of different KPIs for these companies, and if you look at the average KPI improvement that people claim they've had over the last 3 years, they said they've improved the average KPI 15%. So not 15 percentage point, but 15%. And then when we asked them, well, what do you plan for until 2025? Well, they want to improve every KPI. Obviously, they have different KPIs. Some can't be improved that much, some more. And on average, by 25%. So you see companies have much higher ambitions than what they achieved in the last 3 years. And I think that is probably one of the reasons we are seeing this, this growth. So I'll get back to the KPIs here in a second. And I also want to just quickly say, excuse if I'm going fast, but we have only 1 hour. We have a lot of data, and we're getting quite a lot of feedback. The more data, the better. I know for some it may be a little bit, you would like us to elaborate a bit more here and there, but I think that's what the questions are for. So what does Industry 4.0 look like in practice in 2022? I want to give you one example of the automotive industry. I actually visited myself a couple of months ago one of the major automotive OEMs, and I was stunned by what is in these factories in these days. And so I'll go through. One thing is modular machines and equipment. And in this specific case, the machines have become so modular that you can produce a combustion engine car on the same line as a battery car. Those of you who know, there's quite a big difference in the technology that goes into it, but the machines are becoming more flexible. The second thing is you have digital worker instruction. And generally, this is leading to paperless operations. You used to see paper all over these products and parts and whatever, none of that. You have these small automated guided vehicles, in some cases automated robots, autonomous actually, feeding line with parts. That's become very normal. And you have these cloud and browser-based worker assistance software tools that have, in this case, the ability to alert, document quality effects, also about the KPI dashboard. And the KPI dashboard in this specific case is globally aligned in all factories, from the CEO down to the worker. So this CEO of the board essentially has the ability to click down through to every plant on every level, which is thanks to the cloud and this being a globally aligned tool. And then what I think is actually quite interesting is that you have bi-weekly software updates at this point. So if you want to improve something, 2 weeks, you'll have an update. I mean, in the past, we were looking at this just being one-off softwares. Mobile handhelds, so the worker themselves can enter quality defects and take pictures, get information, leading to engagement. The cars all have tags that allow you to see where in the factory is which car that has not been produced yet. So that's via UWB technology in this case. You have a very sophisticated MES system that needs to coordinate hundreds of individual shopping carts that are made to order and then sent to the individual car at the line. You can localize specific tools like drills or something via private 5G, so you know where they are. The body shop is entirely automated with robots and with machine vision system for robot guidance and fault detection. And then we are talking about digital twins that allow people to simulate production upgrades. Or in this case, you want to move the arm from here to there. What would that mean? And not to forget, sustainability is playing a bigger role. In this case, the company that we were looking at, they have the entire roof is made out of solar, so they're essentially powering their entire plant. They're using LED lights, more efficient, and so on. So that gives you an idea of what's happening in the industry out there. In terms of the KPIs, and I am actually going to jump a little bit because I don't want to go to every detail here, but OEE is the #1 KPI across manufacturers, but there are a lot of other KPIs. And the interesting part is that some of these KPIs, so this is kind of the 15 and 25% I was talking about earlier. So some KPIs are just, there's more in it than in others. So you see that cybersecurity is where companies say we want to improve the most. So they want to decrease the number of security incidents by more than 30% in the next 3 years. That is kind of the highest ambition in terms of numbers. Decrease in waste and decrease in safety incidents are the other two big ones. But all in all, there's a lot of improvement, and that's probably what's driving the investments right now. I also want to quickly talk about the challenges, because that has changed as well. This is the only external data I'm sharing, and this is not from us. This is from the Bain IoT survey they do every 2 years. And you see that you can see that here 2 years ago, security was the biggest concern for IoT, and this is mostly industrial IoT here. And now it's about IT-OT integration, about technical expertise. So those are the key concerns. This is what has changed. And this really reflects also what we are hearing from different people who are having major issues with the, first of all, in getting the talent and retaining the talent, but also in combining all these different technologies into a scalable and seamless experience. I'm going to jump these because for time reasons. So I do want to get into closed loop manufacturing and related topics. Now, we talk about Industry 4.0. There are a lot of related themes. And from our research desk, I would like to give you a couple. There's edge computing. The core idea here is that you distribute the computing more locally. And you have things like edge software platforms. I mean, that was one of my biggest takeaway from SBS last week, how every hardware vendor is really looking at their edge software platform setup, distributing. And so we see huge momentum in this whole edge computing, having more local compute. There's the topic of IT-OT convergence. So the idea is you seamlessly integrate IT and OT technologies, things like containerization of OT, low-code tools, IT-based development environments to have PLC programming code. At the same time, the other way around, digital twin of an OT asset. Again, huge momentum. We're seeing a lot going into this area. There's the whole topic of AI and IoT together, AIoT, machine learning. I would say not as big as a momentum, but there's quite a bit going on there as well. And this is where I would place closed loop manufacturing. It's yet another way of looking at optimization with Industry 4.0 tools. But the difference here is you're not looking down the up and down the stack. You're actually looking along the value chain from design to utilization, how you can close loops and how you can make things better. We are seeing some momentum. I would argue that perhaps it's a bit overlooked by some because it's a very interesting way of looking at things. And I do want to note that it is a bit similar to the concept of digital thread, which doesn't really specifically talk about loops, but it talks about the fact that you combine, you have one single digital thread throughout this process, which then allows you to loop back. We'll get to that on the next slide. And then lastly, I'm going to put another upcoming topic on here, is industrial metaverse. There's still a little bit of ambiguity what this all means, and I think different vendors are using it in different terms. At this point, in our view, just an idea or a marketing term for something that already exists. Although it is being used by some of these companies now to talk about the future and dream up what the virtual future looks like. So today we're looking specifically at, we don't have a lot of time, 1 hour. So today the topic is closed loop manufacturing. And as we're going to closed loop manufacturing, I do want to talk about, first of all, what does it mean? So closed loop manufacturing, if you look at the product journey from design, engineering, manufacturing, quality, supply chain, utilization, and then perhaps field service or maintenance, there are loops, if you can. Ideally, in a closed loop environment, whatever you have in quality feeds back into manufacturing or engineering or design. Whatever the customer says when they utilize feeds back to, again, manufacturing, engineering, or design, or whatever the field service technician says feeds back into manufacturing, engineering, or design. So that's generally the idea of closing the loop, allowing yourself to work with data as you go through. So closed loop is the synchronization of product lifecycle activities with product performance. There are a number of key tools for closing the loop, mostly existing general software. So you have CAD for design, you have CAE for engineering, you have MES for manufacturing. You could feed some of this in your ERP. You could have an IoT platform, a bit more modern. Your product lifecycle management is part of this. Digital twin plays a role, and data analytics plays a role. And the whole thing, why are you doing it? With the goal to improve product quality, reduce scrap, increase customer satisfaction. And so today, we don't have a lot of time, but we're going to have a specific focus on the part that sits between manufacturing and quality. We do want to highlight the topic of machine vision, because it's something we are currently in our research doing quite a bit. Fernando has been working on that. And we do want to highlight the topic of IoT platform, again, yet something that we have been researching quite a bit. But Raphael is going to talk about that as well, because they also use an IoT platform for their closed loop. With that, I hand it over to Fernando.
Thank you, Knud. Hello, everybody. So yes, we've been working on the topic of machine vision, and to set things clear from the beginning, we want to first share what we talk about when we talk about machine vision. So we consider machine vision as the combination of different technologies and methods that enable to automate the extraction of image information for providing operational guidance or key data for machines to execute a given task, either in industrial and non-industrial settings. So here we have a short example of the different main components that we have in machine vision systems. So first we will have the machine vision cameras, lenses, and lighted equipment for collecting the images. Then we will have the dedicated hardware and software for processing and analyzing the images. And then a third main component is the camera. There are the camera controllers and the actuators to execute these actions, either stopping the conveyor belt or kicking out some specific parts based on the image analysis. Now, if we move to the next slide, the question is why machine vision is relevant in the context of closed loop manufacturing. So we identified three aspects. The first direct or more evident aspect or reason is that machine vision provide a direct feedback channel for the manufacturing operations. So here, basically, what we're talking about is that having a machine vision solution help organizations to identify issues and trigger actions to compensate that and reduce costs, like, for example, costs related to downtime or reworking faulty parts and scraps. The second main reason is that machine vision solutions provide an accurate and reliable quality control system. So here, when we compare to manual checks or traditional quality inspection systems, machine vision solution can enable a continuous and repeatable performance 24/7 at 100% accuracy quality checks at the time that this system, they can see stuff at an incredible speeds that the human eye cannot. And the third reason that we identify is that machine vision is one of the key building blocks for automated and digitalizing manufacturing processes. So basically, the automation and digitalization is at the heart of nowadays machine vision solutions, since that we observe that many of them come already prepared to the factory floor or to adapt to their specific digital infrastructure. And a last insight that we collected from our investigation is that machine vision ranks as the top ROI use case in all our service, mainly driven by recent advancements in AI, edge compute, and image sensors. Now we have shortly prepared a small example of how machine vision could enable closed-loop manufacturing. So in this case, we have the French company called Numalliance, that they produce CNC bending machines. So here they develop a fully automated tubing production, inspection, and correction system. So basically, the company has enhanced their machines with a robotic arm and a tube inspection cell with its corresponding inspection software, and have connected all these parts together. So basically, the system functions in a way that parts are, metal tubes are first bent with the CNC machines, then they're picked and placed into this inspection cell or chamber by the robotic arm here in the image on the yellow. And then the system and this cell, if you see in the background, inspect the parts and using 3D cameras. And if the system found a defect in the bending profile, the system automatically sends batch correction data to the CNC bending machine and reboots the entire machine bending trajectory without any operator assistance. One interesting fact of this, and it's related to what we highlighted previously on why machine vision is relevant to closed-loop manufacturing, is that the inspection system comes with some factory floor ready features. One of them is that the cell comes equipped with a 3D glass reference surface to accurately track and position the images to compensate for environmental factors. For example, high temperature. So high temperature could turn the generate that, or could make cameras to move, and in that fashion it could affect the accuracy of the position of the images, or the bend, or the calculation of the bending of the tubes. And another thing that the system comes with is that it helps to troubleshoot with a troubleshoot mechanism to flag whenever a camera is blocked or dirty. So overall, the benefits of the solution was that it enables 100% automatic control of part productions, as well as eliminate the string back and elongation defects resulting from the tube or wire bending process. Now we'll hand over to Raphaël, that is going to explain a little bit more about closed-loop manufacturing. Thanks.
Thanks, Fernando. We can see your screen, Raphaël, but we can't hear you yet.
Okay, hello everybody. I'm very happy to welcome you today to my part of my presentation about closed-loop manufacturing. And what actually I just want to rebound on is the fact that Knud explained us the actual situation of the jobs in the industry 4.0 context. And actually, I think that the situation is not so bad, and the reason of that, it's we are now facing an instability in our general situation. I mean, if I talk about COVID, if I talk about war, if I talk about supply chain issue or an energy crisis, I think those topics are even more relevant today for us or for the manufacturers to be more accurate, to be more efficient in the production process. And I think that's also a reason why today the people in this field are looking more and more about what are the solutions to become better. So I think that's one reason why we are not facing right now a bad situation in this field. I will just go into my presentation with the small agenda, just to discuss about the main topics I will introduce. First of all, of course, I will try to introduce our vision of IoT, talk about the difference that we see between manufacturing execution systems and IoT platforms. And then I will go a little bit more deeper into the closed loop manufacturing. I'll try to bring also some use cases of our customers, because I think it's always more precise and more interesting to see exactly what happens at our customers. So that is for the first slide. I would just like to take the opportunity to introduce our company. So IoT Analytics has presented us as also 𝗬𝗪𝗋𝗋𝗋𝗋𝗋. 𝗬𝗪𝗋𝗋𝗋𝗋𝗋 is our IoT platform. It's actually a product, a solution. But our company, Brügge Tools, is an international trading company and service company. And we have three main focus. I would say that the biggest one is the tool and the C-part supplying. So we have a full product range of 200,000 items. Around those products, we have services. We call them the tool services. And those are, for example, application consulting, product lifecycle, and e-business solutions, really around those products that we supply. So at the end of the day, these are solutions to help our customers. And the third field, this is the one where I'm attached. It's the consulting solutions. I'm actually in the Industrie 4.0 IoT field, and next to that we also have some power in the MRO integrated solution and the lean management. Just briefly about myself, I'm working now for 10 years already for the company Brügge Tools. I started as a project manager and then went through the consulting, and now I'm leading this department called Industrial Solutions. Next to that, I'm also the managing director of our sister company. The company is named 𝗬𝗪𝗋𝗋𝗋𝗋. And at this company, we have our software development teams, and we are here with a team of about 10 engineers. And my background, I have worked in the oil and gas industry and the watch industry, and I have degrees in computer science and project management. So now about IoT, or more precisely IIoT, so Industrial Internet of Things. We really think at Brügge, so as an integrator, that this revolution will really accelerate and change the world of manufacturing forever. I mean, there are a bunch of technologies today that are available that allow us to connect machines, but also people, to track data, to collect data, to share those data. And then we also have powerful analyzing tools. And at the end of the day, that are all insights that help us really to manage our productions, or really the shop floors more efficiency, and really to take decision more fast and also based on real data. And actually we are seeing a change or a move between something that everybody knows. So MES, Manufacturing Execution System, is really the traditional way to streamline operation and production, really at the shop floor level. And this is seen really, for those of you who know that term, as monolithic system. So it means it's a hard integration, it's a silo, and it's really going deep into the process, but in a vertical way. And if we compare that to IoT platforms that are maybe on the market for 5 to 7 years, they are much new in it. They are really new in that game. but they have also another way to be integrated into this architecture. So not talking about a vertical, but as a horizontal. So really, we can see them as an umbrella over the whole company. And it allows us really to much more easily integrate different types of services, different types of equipments or softwares. And when we see this really at the opposite of the monolithic integration, we see this as a joint architecture. And I will try to explain you where are the differences of those two main topics. If we look at the architecture right now as we know it, I'm not really sure that IoT platform will replace MES. MES are already very good integrated. They have a very deep understanding also of the process. And I think that the IoT platforms will run parallelly to that actual architecture. It will just bring new solutions, and maybe the transition between MES to platform will be smooth and will take time during the years. But it will not be like the customer will say, I want to exchange my MES with the platform. It will be more evolution. And then after that, we will see which system will take the biggest place in this architecture. If we compare them with some maybe insights or maybe with some key facts, the IoT platform is really seen as a joint architecture between microservices, but not only at the service level or apps level, but also at the edge level. So every objects are seen as different data sources, and we try to connect all these equipments together, linked to a platform. And then after that, all the data are at the same place. And thanks this architecture, it will be much more easy to integrate all the services on top of that. So it means it's really a kind of middleware. The platform, as I said, is really transversal over the organization. And that allows us to have really a high flexibility through the microservices, just using the services we need and not using the one we don't need. Instead of maybe having a big software with a lot of features, and at the end of the day, maybe just using 5% of them. On the IoT field, we also have the chance to be able to join two worlds. These are the edge and cloud world. So it's a kind of hybrid integration, and that allows us really to use the cloud computing, the cloud power that allows us today to make, for example, AI without having a high edge infrastructure. So it's really a data-driven manufacturing environment. And if we compare that to the actual MES integration that I called it already before, a monolithic, and in this case, you can see at the pyramid here, the different levels. So you can find again what everybody knows, the ERP, the PLMs and MES and so on. And this is really seen as a silo. So the integration is going deeply into the detail, but it's not going over the whole organization. And it has a point-to-point integration. And that means doesn't allow us to have the flexibility that we could have in an IoT environment. And all the protocols are more proprietary protocols. That means much more difficult to let the software talk together. So that's for us the main difference between these two words. And actually, we are seeing that not really a war is beginning, but it's a change that will become always more and more present at the customer side, and the tendency is that it will go in the direction of IoT in the next years. There is here another interesting slide showing the evolution through the main milestones in the industry environment. So from the years 1890, we can see there were different type of milestones as we know them, the assembly lines, the mass production, just in time, until the ERPs. And if we look at this optimization gain evolution, we have reached already the maximum of what those technology can offer us. So of course, ERP will not disappear, of course not. but it's difficult to do more today with those systems as they have reached their maximum. And we have other technologies actually that will drive the next evolution in this production environment, because all the machine data available will really accelerate this development. So I tried here to show as, for example, the connectivity, not only with the machines, but also with the people, will completely break down those silos. So this monolithic integration. And this will drive real business outcomes by leveraging advanced analytics and intelligence. So everybody is talking about BI, business intelligence, about AI, and the power of this AI autonomy and efficiency will really open some new doors to go again into an evolution phase where we will reach a new level. So I just wanted to point that out because I think this is a very good chart, and it shows really how the evolution is at the turning level right now, and we are starting a new journey here with some new technologies. There is also another chart that I like to use when we start a project with our customer, is this Industry 4.0 evolution chart. And actually, if you look briefly into these 6 steps, of course, we want to focus on the top of it. And we talk about, okay, I would like to do predictive maintenance. Then we have adaptability. This is the topic of today with the self-optimizing closed control loops. But actually, it's not possible to start an Industry 4.0 project or the digitalization project directly here in the dark blue zone. We have to go through the different steps, and we have to do the job over there. Otherwise, it will never be possible to jump directly to the top of it. But we don't have to forget something, is that each step have some business benefits, even the first ones. So it's mandatory really to go through all those steps, to split the project in different phases. And of course, we need a vision. We need to know where we want to go, but we never have to lose the focus on the actual project. So that is also a very important point. I have now another example I would like to show you. It's a real example from a customer of us, and I want to show the difference between facing a problem with real-time data or without access to this real-time data. So let's take our customer. It's in this case CEO of a discrete manufacturing company. He's named Jimmy, and Jimmy received an order from a customer to produce 10,000 parts. So maybe for everybody, discrete manufacturing means really production of single parts. There is no assembly process. So 10,000 parts to be produced. He has a capacity for producing that part of 150 parts per day per machine. And Jimmy decided to plan this work order on 4 machines. That means he has a delivery time of 5 weeks. But as always, there is a but. Something happened. The customer calls 2 weeks after the start of the work order, and he asked if he could add 2,500 parts to that work order. So what happened? Jimmy has to check what will happen with the delivery time at the end of the day, if he will be able to deliver that parts in the same time without having an impact on the other customer orders. So let's see what he will do. In a first step, in an environment that would not connect the data, connect the machines, he would have a theoretical planning. So 4 machines, work order have started on these 4 machines, and he has to get the data from the people or from the different system. And this is a kind of a manual search process. He will have to check how many parts were produced until today, what was the reason, because he reached maybe not the target that he was expecting. He has to check how many scrap parts they have produced in order to understand what is the room that he has here at the end to be able to produce those extra parts. So this job is possible, but it's a manual job, and he has to go through different kind of information put them together, and then he's able at the end of the day to answer the question. And what happens now if Jimmy has access to real-time data? He will have another type of planning, a kind of dynamic planning. So the planning will show him where he should be right now at the moment. And then he will also display the actual progress. So we can see here, we are maybe late on several machines. We are ahead the planning on some other machines. And also we can see here that we have the detail about this situation. So for the customer, it's much more easy to understand, okay, the downtimes, that was something expected, or the performance issue, that was also something expected. And with all those data, at the end, he has directly the answer of, do I have capacity to absorb this extra 2,500 parts? And I am able to deliver those parts to the customer without having an impact on the deadline and on the next work orders that are planned on those machines. So that's a first example about showing what is the benefit of this connected data. And if you remember my chart with these different blue zones, we are here really in the middle. So transparency and visibility. Let's go now a little bit more deeper in the topic of the day. So closed loop manufacturing. So for us, CLM will lead to a significant change in the discrete manufacturing. And I will try to explain right now why. So let's take a current adjustment cycle on a machine. So again, in the discrete manufacturing field, single parts production. So we have a part that will be produced in a mass production. So we talk about several parts, machines running 5 or 7 days a week, 12, 24 hours a day. And those parts will have to be measured. Of course, not every part, because otherwise it's a huge job. But why do we have to measure some of them? Maybe at a regular time, every day, every 2 days, 3 times a day. It's to understand, we can see it here on the chart. It's to understand if the process is stable and if my dimensions are still in the target. So if I'm not getting out of the tolerance. And at the end, the operator will have to check the result of the measurement process, and will have to calculate by himself if he has to adjust the machine. And then when he has calculated those offsets, we call them the offsets, he will have to input those offsets into the numerical control directly on the machine, and then produce again. So that's why we call this already a cycle. And what are actually the, I would say, point of failures? I said the operator have to input the correctors directly in the numerical control, so there is a risk of inputting something wrong. The operator have to calculate those corrections by himself, so there is also a risk of doing something wrong. And why are we facing that problem? It's also because the parts are always more complex. We always have more complex parts, but this is directly linked to the machine topology also. The machines are always more able to produce difficult parts with more acts, with more tools, with more options. That means the parts are complicated, and it's at the end of the day difficult for an operator to really have everything in his head to understand how should I correct the machine manually. There is also something that is really well implemented right now. It's the statistical process control. So we call them SPC systems. So it's by measuring parts at a certain time, each time of day, and then using those measurement and the history of those data to create some statistics and to understand exactly, okay, how often should I control my parts to be sure to stay in this average or to stay in this acceptable area. So this is totally based on statistical calculations. It's not really linked to machine data or something else. And actually, we are seeing now something coming out always more and more into the closed loop manufacturing, where we really are able to connect machines together, and all this loop is getting always more and more automated. So I have chosen, and I think these are the two contexts where you can see closed loop manufacturing. The first one was mentioned by Fernando at the beginning of the presentation, the 𝗔𝗻 Alliance machine with this bending process machine, an hexagon measurement machine, and a robot. It's exactly this type of machine. So an automation context with some vision, some part detection, measuring tool, RFID chips. And this is something we already see for many, many years. So this is actually not really new. So we call this actually a production cell. We have a machine, the machine is linked to a robot. We have a kind of measurement system. It can be directly integrated to the machine, or as in the example of Fernando, another machine next to it. And this system will measure directly the parts, and we'll be able to autocorrect the machine if we are facing some dimension issues. So actually, this is a typical production cell. As I said, something that is already at production facilities for many, many years. But there is another way to see closed loop manufacturing. And this in an Industry 4.0 context is totally different. So now we will not talk exactly about the same components. We will talk about machines, about connected tools, about master data management and networked components. And that opens completely new doors. Let me explain you. So we will have a production with several machines. So I would say a shop floor with equipments, not only production machines, but also measurement tools, measurement machines. Also talking about software, I have mentioned SPC for the statistical process control. And then we will be able to add new stacks or new components to that environment. And if you look here in the middle of the screen around my pointer, we can see the flow of the part and of the data. Actually, the machine will produce a part. This part will be measured on a measurement system. And this system will generate data that will be stored into the QM system for the history, but will go to an algorithm, and this algorithm will send automatically to the machine the correction. So if you look at this architecture, it's not really anymore talking about a production cell. It's talking about making all those objects talking together and creating a cell with the whole shop floor. So that's actually the main difference with the closed loop manufacturing in the Industry 4.0 context. And just to resume and to give the overview, on the left side of the screen, the first example, and on the right side, the digitalization example. And if you remember my slide back in the presentation, actually, we refined this concept of having a monolith on the left side of the screen, so a standard way of integration. And on the digitalization point of view, really talking about microservice philosophy. Everything is becoming a service or an object, and everything is working together. And we don't have to replace or to buy or to create a new cell. We can use all those objects to make them work together. And that's actually the real closed loop manufacturing concept that we try to show to our customers. And I have tried today to put together some information about a use case. Actually, it's a customer in the watch industry. As you maybe know, a watch industry is a kind of market where people don't really like to talk together. There are a lot of secrets. Everybody wants to keep their secrets and their manufacturing process. But what I can say is this company has 90 employees. As you can see, it's a SME, small and medium-sized company. Was created in 1947, based in Switzerland. And they are specially focused in the Swiss type turning machines. So for the one who doesn't know that, those machines are running normally 7 days a week, 24 hours a day, and they are fed by a bar, and it's like turning and producing parts as a mass production process. So machines that runs the whole day. And this customer came to us and had several difficulties. He said, I have some parts that are always more complicated. So my operators have issues to calculate this correction. I have also some difficulty to find the resources. I think this is a worldwide problem, actually, to find people that are able to fulfill those requirements. And next to that, he also wanted to optimize his OEE. So he had noticed that there is a potential to be improved. And he said, if that can be a side effect of my project, I want to go deeply into this topic also. So let's take the integration process of that customer. So a mass production of those watch parts, a machine park dedicated to those parts of 8 machines, CNC machines, and some measuring equipments. So again, not the measuring equipment dedicated to a machine, but to a workshop, and several kinds of measuring equipments. Then when we take the workflow, again, the part is produced on those machines, then will be measured on those equipments. And then next to that, an algorithm was implemented to replace the human brain. So actually to calculate those corrections. And this algorithm will ingest all this measurement data, will provide to the operator the optimal correction result. And the operator can choose if he wants to apply them directly or if he wants to modify them. And then by a mouse click, he just can send those data to the machines without a manual input. So I mean, all this process is connected, is a kind of loop. Actually, it's the same diagram that I shown before, but here with some details. And all of this is running together. And next to that, he has also access to the real-time data. I don't know if you remember our first use case, our COO who needs to access those data to understand his planning. This is a side effect of the project. And he also have all the statistics. So when we talk about measurement, we have to store all those measurements, and all of them are also available in a SPC system. So actually, this is a real closed loop integration based on the equipments that the customer had already before. And it's not a new production cell that was created specific for that project. It's really using the actual equipments and make them talk together for, at the end of the day, having a closed loop concept. So that was our use case. And the project benefits, of course, it was the first goal, also increase the production efficiency. And what are the details? We have a minimum adjustment time because the closed loop allows us to do it very fastly. Also a very easy training of new operators because the algorithm is also there to support those guys. A reduction of scrap parts because there is normally no mistake into those auto corrections. The side effect of the 20% increase of the OEE. The quality KPI increased by 50% because, of course, again, the algorithm has always normally the better proposition to input the correction to the machine, and also no production stop due to input errors, what was actually the case before. So the real insights at the end is a really tangible machine capacity release with more capacity. And then also, of course, that was for the CEO of the company a very strategic project that allows also to maintain a high level of production. And despite unforeseen events such as some staff unavailability, new operator training, and so on. So I mean, all those difficulties that he had at the beginning was solved with the implementation of such kind of a project. So that was actually my explanation and our understanding of closed loop manufacturing. I would like to thank everybody for attending this webinar. If you have specific demands or questions, you can reach me by the different channels, and we will have a little bit more time right now to answer some questions if you guys have some specific questions. Thank you very much.
Thank you, Raphael. And we do have first questions that have come in. And maybe for those on the webinar, we're happy to go over a little bit to make sure that we answer all the remaining questions. So, and I invite everyone who has any specific questions on what's been shared to share that in the Q&A button right now. So there are a couple of questions that are actually for Fernando and my part. Maybe there's a couple of quick ones that came in earlier. There's one question on the example I showed earlier of the automotive company, and the question is, how is it possible that tools are being located implementing private 5G? Just a little bit of background for that. Private 5G has a technology called millimeter wave that allows for indoor positioning. If you have a couple of different routers and you put a small modem, in this case on the power tool, you can localize things to a meter or below level. And that's what, in this case, the car manufacturer is experimenting with at this point. Private 5G is a lot of experimentation. So I hope that answers the question on private 5G and automotive. There is another question that has come in on the topic of MES versus IoT platform. It's actually a little bit more of it's a long statement, so I need to see what I write, I'm just going to talk about it here. There are, and actually before I do that, let me do one more thing. I know we're going to be, a lot of people will jump off here in a minute. But before that happens, I would love to get your feedback, just for us to understand, you know, where, how did we do? What can we improve? What was good? So I just shared in the chat to everyone a link. It would help us a lot if you would fill this out and just live 1 minute. Just leave us your note. What was good? What was not so good? What can be improved? We always want to improve. Back to the questions. There's someone who says those views on manufacturing execution system being monolithic, point-to-point, standalone, seem to be outdated. Modern MES have moved on and contain and integrate several applications, quality, supply chain, warehouse management, and also incorporate modern technologies, AI, predictive maintenance, and so on. They also allow bidirectional data exchange, and so on. The question is, shouldn't the picture be that in future, MES and IoT platforms grow together, combining the best of both worlds? Raphael, I don't know if you want to take some of that. I'll give you my perspective. I think there's a certain, the person who asked it, I think I agree to some degree that they are coming together. I see the MES companies have done big steps in the last 3 or 4 years to move away from monolithic. But I would also say some of them have struggled quite a bit in moving their old platforms into containerized, modern, microservice-based services. And I have not seen a lot of MES companies do this so successfully. In fact, I think I've talked to a few people in the industry who said they felt that most MES players have not managed to move away to really cloud-based, cloud-native, containerized, and so on. And I know, Raphael, if you have a point of view on that.
Yeah.
I still agree, though, that the two worlds are converging and should be converging.
I also mentioned that at the beginning of my presentation. I said I think the two worlds will be combined together, and I don't think that one will replace the other one. The only point I can say is that in the software world, we are faced to legacy problems. And I think an MES provider or supplier that has provided MES services for already many years, he's facing a certain legacy. And to jump from this old type of software to a more microservice oriented software, he will face some different problems. So that's why, of course, I tried to show really the two contrary and to really explain to the people who are not really deep into this to understand exactly the difference. But I also agree that there is no really a black or white answer. I think some MES supplier will jump into this new world. Some of them will struggle, and also some new players will come in the game, guys coming from the IoT world.
Yeah, and MES is an extremely fragmented market. We've done some market research on that in the past, and there are some players that are super small and have very specific solutions for some industries, and some of them have not moved much and are just holding together what they have been doing in the past. Next question is on APC algorithms. So Raphael, that one's for you. You talked about APC algorithms. Can you elaborate on those APC softwares?
That's a very good question. So APC, we use APC to say automated process control. And the idea of those algorithms is to autocorrect the machines. There is different type of approach. In the case of the customer I've shown in my presentation, this is a self-made algorithm. So because what is the link between the algorithm, the machine, and the part? Actually, it's the geometry of the part, is the type of the machine, and all these parameters have to be done together in order to create a result at the end of the day. So yes, in some case, we will elaborate by ourselves the APC, and in some case, we also can use APC algorithm from the market. So we can send the measurement data to the APC from a third-party software and get back the result and send them to the machine, exactly in this microservice philosophy.
Good. There's a follow-up also from the same person who asked, can the closed loop manufacturing be run on the cloud or at the edge?
Actually, the closed loop manufacturing can run on both sides. It's not a process that is really needs cloud power. So we can run them on normal computer on the edge. It's not like, for example, AI that would be, for example, almost impossible to run on edge. In this case, we really can use both of architecture.
Got it. Not sure you can answer that. There's a question on whether closed loop integration is part of continuous improvement with regards to the process industry. So I'm not sure if you're, well, you come from an oil and gas background, so I don't know if you can answer that.
Yeah, I think the continuous improvement, of course, that is the way of implementing this process. The closed loop integration in our case is really an automated process where everything is working together. But of course, at the end of the day, it's the philosophy of continuous improvement.
Right. Let me see. One question is, how does it work to connect older machines if you want to have a closed loop system? Do all the machines need to be new?
Yeah, in some cases, the machines are maybe not connectable. That's also possible. I mean, the very old machines are maybe not ready to receive correction via the network. So that can be a problem. But normally those machines are not running such kind of complex parts. And that means we don't need the closed loop manufacturing on those machines. And on the other one, we don't really need new ones. With the actual protocols that we have, or the actual communication possibility that we have with OPC UA, with MT Connect, with Focus, and so on, there are bunch of possibility to send the data to the numerical control. So that means no, the machine should not be new. And yes, it can be a problem if the machine is really old, but that should not be a problem because normally the parts would not be so complicated.
Thanks. Yeah. I will continue to read some questions as they come in, and then we end it here. And I mean, for everyone who has to jump off, feel free to jump off. We will send the recording. So another question is, and this is again more of a statement with a question. Closed loop is more about getting optimum and dynamic control on the production machine, but analysis of the production machine sensors. It's really a question of big data processing. This is where industrial IoT differs with IoT, and microservices are not the answer. How do you see these challenges? Not sure I fully understand the question. Do you?
No, not really. I think, yeah, of course, we can really differentiate IIoT and IoT. And when we say microservices are not the answer, I'm not really sure, because at the end of the day, the goal would be to use the right algorithm in the right context. Of course, it's not a microservice as the ones that we can find on AWS or on Azure. But in the edge integration, we still talk about the service that is separated from all those modules and that will deliver data in order to correct the machine. So I don't know if I get really the point about the questions, but if it's really to differentiate microservice, IoT, IIoT, of course, these are two different words, and I don't know if we can really compare everything.
No, I mean, also from my observation, I mean, microservices, I mean, the way I look at it is another way to look at it is like the containerization of things, because you can only offer microservice if you have containerized your architecture. And I mean, boy, SPS last week, when I went around and tried to see what's happening with all these different control vendors and all kinds, everyone is working on containerizing software on those devices. That is like the thing right now, and it is the answer to everything, because only then can you modularize the whole thing, run specific applications, have a continuous, have some things running in the cloud, some things running. It only works with containers, and so. Again, I think microservices and containers are the answers to most of this for future software engineering. One specific question is coming in on how do you link the measurement with the correction? Is it manually the first time?
It's a very good question. Actually, we can do both. If the measurement equipment is not able to deliver the data, then it will be delivered by the operator. I mean, he will measure on the machine and he will provide those results to the algorithm by entering at the keyboard, for example. But today, most of the measuring equipments can be connected to a computer, and there is somehow a way to get those data directly into the algorithm. But of course, both ways are possible. And this is exactly something that is directly dependent of the devices that we are in front of. So both are possible. It's not mandatory to do it manually first. It can be directly automated. There are several possibilities.
There is another question that came in on the topic of unified namespace. I don't know if you're familiar with that, Raphael. The question is the architecture the same with the unified namespace?
Yeah, I think a unified namespace is something that helped the industrial IoT. I'm not really a big expert into that question, so I would not be able to really answer if it's exactly the same or not. I don't think so. I think the unified namespace will support industrial IoT to be able to do some type of things, but is not totally the same.
Good. I think we leave it here. As far as I can tell, most of the questions are, or all of the questions actually, that I have remaining in the chat here have been answered. If you do have more questions, either to Raphael or to us here at IoT Analytics, I hope you have the means now to reach out, have our contact details. If not, you will receive an email in the next days with a recording. You can reply to that email, obviously. We'd be happy to talk more about it. It's a fascinating space. I think closed loop in many instances is not realized yet, specifically for small and medium enterprises. I think we also have to see, we often see the big flashy, I mean, I gave the example of automotive OEM, like that's kind of the North Star, but the reality for a lot of the small and medium-sized companies is oftentimes quite different. And so it is great to see that you guys, Raphael, are doing a lot of work in this area, helping companies connect things and close the loop. Thank you very much. Thanks for everyone who attended. And I look forward to meeting with you, hearing from you, and engaging with you at some point in the future. Thank you and bye-bye.
Thank you, everybody. Bye-bye.